currently taking or soon to be enrolled in a recognized broadcast or digital media program in Alberta, Saskatchewan, or Manitoba, you may qualify for one of two Pattison Media $2,000 Prairie Equity Scholarships. Details and application forms available through the Prairie Equity Scholarship link at big105.fm. Application deadline October 8th. Our industry needs your voice. Unbelievable. This Cinderella story is one putt away from winning it all. He did it! The youngest ever to win the Lakewood Golf Championship.
Whether you are new to the game, would like to meet new friends, or compete in the highest level golf tournaments, sign up for the Lakewood Junior Golf Program. Learn from CPGA head golf professional Scott Bergdahl and his team of instructors about the ins and outs of golf. Golf course etiquette, swing and short game fundamentals, and more. Visit LakewoodGolfResort.ca to learn about the Junior Golf Program.
The sun is smiling, and so should you. At House Dental, their team of general dentists will help you bring out the smile you deserve. Accepting new patients, General Dentist Dr. Lindsay and George House and Dr. Miranda Long, across from the Portal Hall Safeway.
Smile, smile, smile. It's the Retro Lunch. Pick up that rotary phone, give us a call, and let us know what you think. All the best 80s, 90s, and more. The Retro Lunch on Red Deer's best music. Big 105. You're listening to the Retro Lunch with Angie Hines.
1993, what a year for techno, hey? Who knew a small group from the Netherlands would make such a hit, and after 28 years now, that song is still lit. No Limits, Too Unlimited on your Retro Lunch. What a jam. Let's get into Theory of a Dead Man, Santa Monica.
She fills my bed with gasoline. You think I wouldn't notice? Her mind's made up, the love is gone. Someone's trying to show us a sign that even if we thought it would last, the moment would pass. My bones will break and my heart will give. Oh, it hurts to live. And I remember the day when you left for Santa Monica. You left me to remain with all your excuses for everything. And I remember the time when you left for Santa Monica. I remember the day you told me it's over. It hurts to breathe. Every time that you're not next to me, her mind's made up, the girl is gone. And now I'm forced to see the thing come on my way. Oh, it hurts to live today. She said, don't you wish you were dead like me? I remember the day when you left for Santa Monica.
Hi, everybody. I'm here. Let's get you guys going here. All right, our plan today. Let's just do a check for the system here. Holly, can you give me a thumbs up if you can hear me? Thank you. Anna, would you say good afternoon to everybody?
Good afternoon.
Thank you. Anna Laura, give me a thumbs up if you can see my screen, please. Thanks, guys. We're ready to roll. All right. Friday, a beautiful Friday. I hope you guys got outside between classes or for lunch. It is supposed to be a gorgeous weekend. All right, everybody. Job number 1, we're going to go through page 10 and 12. So I'll get you guys to open up to page 10. All right, and I'm going to call on people to share their answers with us. And we'll see. I don't think we'll have too much to debate or discuss. It's pretty straightforward stuff. Let's have Ava Adams. What did you say for A?
I don't have my booklet right now, but I'm trying to get it. Like it should be here soon, but I don't have it right now.
All right, I'll get you just to go ahead and read it on here.
Okay.
And you can tell us what you think.
I think what like Josh thinks he's gonna get is pretty correct because it's like basically just half and half.
So how did he make his prediction? You have these three choices. So what do we call that when we use the numbers and we say it's half and half? What kind of thinking is that?
Theoretical probability?
Yeah. Okay, so Ava kind of said the main thing here, the half and half idea, right? If you think about what's going on, there's 5 red, there's 5 blue, there's 10 in total. So if we were finding probability of picking a red marble, we'd say, well, 5 out of 10 marbles are red. And in simplest form, that would be 1/2, which could also be written as 50%. So Josh is using numbers to figure out what should happen. So his decision is based numerically on what should happen. All right, thank you, Ava. Let's take a look at B. A quality control officer for a light bulb manufacturer tested 10 light bulbs. 9 of the bulbs burned for more than 1,000 hours. So the manufacturer decides that 90% of the light bulbs will burn for more than 1,000 hours. Killian, what do you think on this one? How did the manufacturer make their decision?
I'm not done that one yet.
All right, we'll have you read it right now and tell us what you think.
They made the decision based on results.
Yep. So basically they did some experimental probability. They tested, they got results, and they based the decision on the data collected, or we could say it was based on what has happened in the past. All right, C. A pair of concert tickets is hidden in an envelope. There are 3 envelopes to choose from: red, green, and blue. Desi chooses the green envelope because green is his favorite color. Ethan, how would you describe the way Desi made his decision?
He picked the last option.
Yeah, totally just based on his thoughts or feelings. Now, what we call that is a subjective judgment. He made a subjective judgment. It was subject to his mood, his opinion. Sometimes it could even be subject to the people that were there at the time. So it could be subject to all kinds of things, but he did not use numbers to figure out what should happen. He did not do an experiment and use the data. So this is called subjective judgment. All right, that's going to give us a nice little warm up into the notes that we'll be doing to finish this lesson. But before we do that, please turn to page 12. And what we're going to do when we go through this, you guys, is we're not just going to answer the riddle, but we're going to answer each question. So have your answers ready when I call on you. So the very first one, suppose you roll a regular six-faced die. How many equally likely outcomes are there? It's like a tongue twister for me. Katie, what do you say? How many things could happen when you roll the die?
6.
You bet. So when we say like how many outcomes, we're talking about how many different results, how many things could happen. If you roll the die once, what is the probability of rolling a 3? Ava H., what do you think here?
1 out of 6.
You bet. So you think about all the things that could happen. Here's all of the possible outcomes. So we've said there's six things that could happen. One of them is 3. Now I'm going to throw a side question at you guys here. Everybody figure out, what is the probability that a number greater than 4 is rolled? A number greater than 4. Anna, what do you think?
1 out of 3.
And where did you start before you reduced it? What did you say?
2 out of 6.
Yeah. So we look at all the favorable outcomes. So there are 6 things that could happen. We figure out which ones are favorable. These ones are favorable, so Anna started with 2 out of 6 and reduced it to 1/3, which was perfect. Now, this next question is not probability. It uses probability, but it's not asking you for probability. It says, if you roll the die 60 times, how many times would you expect to get a 1? Do we have any volunteers for this one? It's a little bit of a different question. Anybody want to give it a try? Emma, what do you think?
Would it be 6 times?
It is not 6, but I'm just trying to figure out where you might have gone wrong there. So we're rolling it 60 times. Let's start. Let's see if you can find your mistake here, Emma. Let's start with the probability. And then see if we can go from there. This might help everybody because, like I said, this question is a little different. It's not like the other ones, so you were kind of left to your own devices here. So I'm going to start with the probability of rolling a 1. So there's 6 things that could happen, and only 1 out of 6 is a 1. So in other words, if I rolled the dice 6 times, I would get a 1 out of 6 times. So now I want you to come up with an equal fraction. What if it was out of 60 instead of out of 6? Sorry guys, when you raise your hands, I miss it sometimes because I'm not right at my computer. So I think we have lots of volunteers. Would someone just turn their mic on and let me know?
Would it be 10?
It is 10. Because if I multiply the bottom by 10, I have to multiply the top by 10 as well. And so 10 out of 60 rolls, we're expecting to be a 1. So guys, question I is very similar. I want you to have a second look at it in case you needed a little bit of help there on H. Everybody take another look at I. So if you roll the die 30 times, about how many times would you expect to get a 5? Now let's go through the steps here, you guys. First, I want to know what is the probability of rolling a 5. Faison, can you help me with that one? What's the probability of rolling a 5?
1 out of 6.
Yeah, that is our starting point. Thank you. Now, all we want to do is convert this into an equal fraction, but instead of being out of 6, we want it to be out of 300. So I'm looking for the numerator right there. Charlie B, can you help me out on this one?
So basically, if you times 6 by 300, well, like, if you times 6 by 50, you'd get 300, so 1 times 50 would also just be 50.
Nice. Thank you for that explanation. So we would expect to roll a 5 50 times if we actually rolled the die 300 times. Guys, any questions from that section about rolling the die? All right, let's go on to the spinner. Now, the spinner is a little bit of a different question again. So before I ask you for your answers, I'm going to give you a little hint, and I'll give you time to kind of check your answers over before we start volunteering. So when we were working with the die, up here we had 6 equally likely outcomes. So we knew we're just as likely to roll a 3 as we are to roll a 5. Well, that's really, if we're doing theoretical probability, which we are, right? This is not based on data, right? We're getting our answers based on what should happen. Well, it really only works if everything has an equal outcome. So right now, the way this spinner is set up, we're more likely to get an A than a B. We're more likely to get an A than a C. So the way that the spinner is right now, they're not equally likely. However, if I divide this into 2 quarters and just name this one A and this one A, and now they're all equal size, now I can go ahead and do theoretical probability. So when you think about your outcomes, actually, to make this maybe a little more obvious, I'm going to make one of them green and one of them red. And over here, when I give all my possible outcomes, I'm going to say that you could have a green A, you could have a B, a C, or there's another A in there as well. So those are the possible outcomes. So now that I've given you that hint about make them all equally likely, take a moment and just go through your answers. See if there's anything you want to change in this section. Okay, so I'm going to look for a volunteer on the first one. If you spin the spinner once, what is the probability that it will stop on A? Who would like to give that one a go? Kaden, what do you think?
1/2.
1/2. And you know what? There's a couple ways to get there. If I'm just using my common sense and I'm not even really worried about the numbers, I could look at the spinner and just say half of the space is taken up by A. So half of my spins are going to land on A. I could also use my little setup here of looking at all the things that could happen. And I could say, oh, there's 4 things that could happen and 2 out of 4 are A. And then reduce it down to be 1/2. All right, let's look at question A. Looking for volunteers here for question A. Probability that you will stop on B. Charlie B, what do you think?
1 out of 4.
1 out of 4, you got it. So again, couple ways of thinking about it. You could just look at the spinner and say 1/4 of the spinner has B. Or you could go over to our list of possible outcomes over here and say there's 4 things that could happen and 1 out of 4 is a B. Okay, if you spin the spinner 50 times, how many times would you expect to stop on A? Now remember, we already have probability of A. So in our very first question here, we said the probability of A is 1 out of 2 or half. Who would like to tell me how many times? Kaden, I'm not sure if your hand is up new or if it's from before. Do you want to tell us this one, Kaden?
No, I meant to lower my hand.
Okay, no worries. Any volunteers for this guy? Annika, what do you say?
25.
You got it. Good job. So again, we know that 1 out of 2 spins will come out to be an A. All we really need to do is turn that into an equal fraction where it's out of 50 spins. So I'd multiply the bottom by 25, multiply the top by 25. 25 out of 50 spins would be A. And then using just your common sense, your number sense. From question A, we know half of the spins will be A. So we're really just finding half of 50. Now, what about 80 spins? How many would we expect to stop on C? Based on what do you think?
20 times.
You got it. Nice job. Because probability of landing on C would be 1 out of 4. So 1/4 of the spins will land on C. All right, we're on to the marble question. Let's see what you guys think about this one. So probability, if you choose 1 marble at random, probability that you choose a black. Charlie C, what do you think for probability of black?
%30.
So, well, you know what? We're going to check your answer. You've given me your answer as a percentage. So let's see here. We would start in fraction form and say that 3 out of 10 would be, that's the probability of drawing a black, and so that would be 30%. Now, I didn't really look ahead here to see at the bottom of the page. So they have not specified that we want percentage. So we will just go with fraction form on this one. So really you only have to go to decimal form or percentage form if it's indicated in the question. Let's go to S. Probability of drawing out a striped marble. Holly, what do you say for this one?
I got 3/5.
Good. So final answer 3/5 would have started at 6 out of 10 are stripes, but best answer 3 out of 5. A probability that you draw a marble that is not black. Jerry, what do you say for this one?
7/10.
Yeah, there are 7 that are not black. 7 out of 10 are not black. Okay, probability of not white. Bailey, what do you say?
9 out of 10.
Yeah, and I want to show you something that we wouldn't have to use really in grade 9, but coming up in your future math, we could use the complement. So if I look at, well, what is the probability that you get a white marble? It would be 1 out of 10. Well, if 1 out of 10 draws, it is white. All the other draws, it wasn't white. So you could just count them, or you could also go and use the complement, that is called. Okay, probability of drawing a yellow. Maddie, what do you say? Not sure, maybe Maddie.
0.
Oh, you are connected. Yeah, perfect, because 0 out of 10 marbles are yellow. Now, 0 out of 10, just like any fraction, it does reduce down to be just plain old 0. Well done. All right, guys, any questions there on the marble section? Okay, so here, first one, if you flip a coin 150 times, how many times would you expect to get heads? Alora, what do you think?
For N?
Yeah.
75.
That's right. Any questions there? Okay, Ty, would you do K for me? If you randomly pick a date in April, how many equally likely outcomes are there?
I don't know how many days are in April.
Okay, but you do know that that's what we need, so yes.
Is it?
You are on track there. Yeah, 30 days in April. So if you're picking a date, 30 different dates could be chosen. The letters A, E, I, O, U, and Y are vowels. If one letter of the alphabet is chosen at random, what is the probability it is a vowel? I'll take a volunteer on this one. Charlie B, is your hand up for this question? What do you think, Charlie?
3 out of 13 when you simplify it, because it was originally 6 out of 26.
Nice work. So 6 out of 26 letters are vowels, and reduces down to be 3 out of 13. Okay, so I'm going to ask on a card player for this next one, somebody who knows the deck of cards. A magician asks you to pick a card, any card, from a standard deck of 52 cards. What is the probability of picking an ace? Okay, card sharks. Who's a card shark out there? Bason, is your hand up right now for this one?
Would it be 1 out of 13? Wait.
Yeah, you're right. Now, card sharks out there, you guys know that there's 13 cards in one suit, right? And 1 out of those 13 cards is an ace. So it's kind of interesting that you might start off by saying, oh, there's 4 aces in the deck. So you might start by saying 4 out of 52 cards are aces. And when it reduces down, you really get it reduced down to be how many in one suit are aces. Now, does anybody want to give us the answer to the riddle? When the boy tire maker married the girl tire maker, what did everyone say? Holly, what did everybody say?
They make a nice pair.
Oh, I love it. That's a good one. They make a nice pair. Good job. All right, guys, we're going to finish off our lesson 1 notes now. So let's pick it up where we left off yesterday. So we were just getting into probability in society. So our focus is to explain how probability is used outside the classroom. We can use probability to help us make decisions. Sometimes the decision we make are influenced by our state of mind or by our gut feeling. When we make a decision in this way, we make a subjective judgment. For example, I think I did well on the test because I wrote in red pencil, and red is my favorite color. So absolutely not based on math, not based on an experiment, totally just a gut feeling. Do we have anybody out there who has those kind of why do I have the wrong word? Superstitions, that's what I'm looking for, on exam day? Does anybody have some secret on exam day? Holly, what's your superstition?
Me and a friend, we do this weird pinky thing.
Sorry, you did what?
We have this weird pinky thing where we connect pinkies, and it's kind of like a good luck charm.
And do you do it every time you have an exam?
Yeah.
Oh, that's cute. Charlie, I think you said you had one. What do you do?
It's not really like a superstition. It's just to make sure I know somewhat of the algorithm of the test on, say if it was like multiple choice and like A, B, blah, blah, blah. It's just understanding if I chose like just the speaking of statistics and probabilities, like the probability of the next one to be B and blah, blah, blah.
Oh, so you like to know like how likely things are on a test, like how many options are there? Yes. Anybody else? No? I used to do a weird thing when I was your age. And you know what? When I was in high school, people didn't really wear sweats unless it was to exercise. Like it just wasn't a thing. But on exam day, I always wore sweats. I always wanted to be super comfortable on exam day. It seemed to work. So I'm gonna recommend that one to you guys. Make sure you dress comfortably. Okay, our first example. Emily was the first to arrive at 9 of the last 10 volleyball practices. So coach thinks Emily will arrive first for today's practice. Is the coach's prediction based on theoretical probability, experimental probability, or subjective? Now, we've already done a group of questions just like these, so we won't spend a lot of time on it. But for example 1, I'm in the wrong section here. For example 1, how is the coach making their decision? Anybody want to take this one on? Theoretical, experimental, or subjective judgment? Okay, let's take a look. So this very first sentence here, you know what? When you read it, it's almost giving you the probability. So what has happened in the past? Emily was first to arrive at 9 of the last 10 volleyball practices. So data has been collected. This is what has happened in the past. So coach thinks Emily will arrive first for today's practice. So it's a little bit of a gamble, but it is based on data that has been collected. So experimental probability, because it's based on what has happened in the past. And I'd say it's a pretty safe bet, because if we wrote that as percentage, that's 90%. So Emily's first 90% of the time, so I'd probably agree with the coach and think she'll probably be first again. Let's have you guys just do one here for a little warm up. Everybody go ahead with number 1. And Kendall, we're going to go to you for our answer on this one. Whenever you're ready.
I haven't figured it out yet.
Okay, let us know when you're done. Does anybody want to steal this question?
I think it's the middle one.
So based on theoretical. Now, I gave you a little hint here when I circled that word right there. So if a survey was done, and from the survey, the data shows us that 5 out of 6 people wore jeans to school, and then Felix decides that if he was to check out 6 students, that 5 out of 6 would be wearing jeans. He's actually basing his decision on results of a survey or experiment.
May I just say, it says a school survey finds blah blah blah, and then it's either based on a survey or experiment. So
yes. So are you kind of saying it's almost just like a careful reading kind of question? Seeing that survey in there? All right, we won't spend any more time on this type of question, But are there any questions about the 3 different ways to make a decision? All right, so we're gonna just bypass this question right here. And let's go ahead to the next bit that is about assumptions. So sometimes when we make a decision, we take certain things for granted. When we do this, we make assumptions. Now, I'm going to say that lots of times you see information, let's say in an advertisement or maybe in a political campaign where they throw numbers at you and say, oh, this percentage of people are unemployed, or this percentage of schools are underfunded, and all kinds of information might be out there. But quite honestly, the people who put the information out there are lots of times they're kind of hoping you will make assumptions. And sometimes those assumptions are how you kind of get sucked in to believing what they want you to believe. So you have to be careful when you are looking at data that supposedly has been collected. All right, example 2, we're explaining how assumptions affect probability. A health magazine claims that people who exercise 3 times per week for an hour each time reduce their risk of developing heart disease by 40%. Now, don't even read another word. Let's say you're doing some homework on your computer and up pops this little window and you get this information. First thing you should do, of course, is be a critical thinker. Like, that statement doesn't bring anything else. Like, what are they considering? Is the only thing they're considering your exercise habits? Like, there's a lot of other factors to consider when we are talking about heart disease. Okay, if we keep on reading, Monique plays soccer 3 times a week for an hour each time. So Monique thinks she has reduced her risk of developing heart disease by 40%. All right, when she makes that decision, she is making some assumptions. So question A here, they've answered for us. What assumptions is Monique making? So she assumes that no other factors increase the risk of developing heart disease, right? Because they haven't even mentioned them. All they talked about was exercise habits. But she should be considering things like eating habits, family history, age, blood pressure, exposure to smoking. So they're not considering all the factors. And then B, how might the outcome change if the assumptions change? If Monique eats a lot of junk food, or if she lives with people who smoke, Monique's risk of developing heart disease might increase. So when they say here about how might the outcome change, we're talking about this original outcome of decreasing her chances of heart disease by 40%. Her chances of heart disease might increase. They might be higher than 40% if she eats a lot of junk food or lives with people who smoke. Now, when it says how might they change, you have to think of kind of like improvements. Like, could it get better? And how could it be worse? You have to think about both ways that it could change. So the second part, if Monique's family has no history of heart disease, she lives with non-smokers, and she eats a healthy diet, her risk of developing heart disease might decrease. So notice how they have included both ways that her chances could change. All right, here's our check, some questions for us to do together. For each situation, A, what assumptions are being made? B, how might the outcome change if the assumptions change? So number one, Sam thinks more people purchase ultra white toothpaste than Shine. So here's an advertisement that Sam has seen someplace, maybe a billboard, maybe newspaper, maybe it's a pop-up on Instagram. He reads this and he thinks, oh yeah, that means more people must buy ultra white because 2 out of 3 dentists recommend it. So these first few questions are sort of going to help us to figure out what kind of assumptions are they making. So Sam sees this sign that says, your dentist says that you should do this. Well, do you listen to your dentist all of the time? Let's see some heads nodding or shaking. Do you do what your dentist tells you to do every time? Oh, we got some people that say yes, but I see a lot of people are like, no. I'll give you an example. I'll say that I sometimes listen to my dentist, but not all the suggestions. I lost an old filling, very painful, by the way, because I was eating jujubes and it stuck and pulled it out. And my dentist said, you should not be eating jujubes. Well, guess what I was eating last night? Jujubes. So I am going to say no. And judging from what I see from the class, most of us don't listen to all of the dentist's suggestions. Does the cost of an item help you decide whether to purchase it or not? Absolutely. Right? If I'm looking at these 2 brands of toothpaste and one of them is twice as expensive as the other one, I'm probably not going to buy the expensive one. Would you make a trip to a specialty store to buy toothpaste? Let's hear from anybody who says yes, because I'm wondering if anybody does say yes. Would you be like tapping mom on the shoulder, hey, can you give me a ride across town? I need to go to that special store for toothpaste. Anybody? Probably not. All right, so they've led us really into the thinking here. What assumptions has Sam made? So we're just going to talk about these things as in terms of an assumption. So first one is that that all people listen to their dentist. Or I guess we should say all people follow dentist's instructions. And the next one was about cost. So he's assuming the cost doesn't matter. And he's, I guess, also assuming that both brands are readily available. Like, oh my goodness, what happens if you can't even buy them in your hometown? Are you going to go somewhere else or order online? Would you go to that much trouble? All right, now part B is talking about if the assumptions changed, how could the decision or the result changed. So we're going to look at fewer people might purchase ultra white. We're also going to look at more people might purchase ultra white. So fewer people might purchase ultra white toothpaste if its cost is less than that of Shine. And if it is only available in, I was looking at the other one, fewer people, hopefully you caught that and didn't put less. Fewer people will buy it if its cost is more than Shine. And fewer people will buy it if it is only available in special stores. More people would buy it if its cost is less than that of Shine. More people would purchase if it is available in all stores where toothpaste is sold. So guys, this one is really, fill in the blanks, really leading us into the assumptions. To be honest, if I was doing this one all myself on just a fresh, no hints, no suggestions, I really doubt I would have thought of specialty stores. I probably would have thought about cost and the idea of actually following your dentist's suggestions. What I want to point out to you is when it is all up to you, there's more than one right answer here. There's all kinds of reasons and assumptions that you might think of. So on this next question, we do not have as much guidance as we did on that last one. So I want you to give this one a try. And here they don't really give us a lot of hints, when you first go to do your assumptions, it's like, wow, we're just got to come up with this on our own. However, here's a good hint. Read, if you have a hard time coming up with the assumptions yourself, a good practice is to read the entire question and get more input and then come back and try the assumptions. So everybody give this number 2 a try. And I'll be looking for your input. So I want lots of good ideas here. All right, so Salima has scored more than 10 points in her last 5 basketball games. With 15 minutes left in the game, Salima has 4 points. Salima has scored as often as she usually does so far in the game. So pretty much this is how the last 5 games have all gone. 15 minutes left, and she's only scored 4 points. But by the end of the game, in the past 5 games, she had more than 10 points. So Salima will score at least 6 points in the remaining 15 minutes. So this is the decision or the prediction that's being made. And I need you guys to tell me what assumptions have they made. So what we have to do is think about, well, what are some of the things they haven't considered? Factors that would play a role here and they haven't considered them. Who would like to give me one of those factors? Nobody volunteering? Okay, well, let's see. Now, when I'm really stuck, I always read the other part of the question. So this part right here gave me some ideas. They're talking about the opposing team. Now, maybe those last 5 basketball games were being played against some of the weakest teams in the league, or vice versa. Maybe they were playing the toughest teams and now they're playing the really easy teams. So I'm going to put something along those lines. The opposition is same strength. Excuse my shorthand here. As the last 5 games. Okay, so maybe she only scored 10 points because those teams didn't have very good defense. Now I'm sure my next one that I have on my list, I'm sure somebody else has thought about it. Let's see. You guys are all being too shy. Ava H. You are a swimmer, right, Ava? Now, in your swimming, what might happen to you that will make it so that you don't have as good a results as you've had in the past?
Well, some days you might be like sore than others, so like you're not doing as good that day.
Yeah, so just physically not in the same, I guess, the same shape. So physical condition is the same. Or actually, let's put Salima's. Physical condition is the same. Okay, so let's look at if the assumptions changed, how would the decision change or how would the result change? So Salima may not score 10 points in the game if the opposing team is higher in the standings than Salima's team. So they're playing a really tough team. She might not get her 10 points. And then as far as the physical conditioning goes, Salma is playing, how about we say injured? So maybe the day before this game, she twisted her ankle in practice and she's playing hurt or injured. Okay, and then we're going to look at Salima may score more than 10 points if the opposing team is lower in the standings. And what else would she maybe score more? Oh, I know. Her shooting improved this week. Due to extra practices. So maybe Salima came into the gym every morning this week and did some extra shooting practice. So again, these are not the only ideas. Does anybody want to try out some of their ideas on us? Charlie B, what do you want to tell us?
If she's still playing like the same ability and strength as she was all her other games. That like instead of like her playing like her physical condition, it's just that she's just playing at the same level as she was at the other games.
Sure. Yeah, that would be fine. I get that one. And for some reason, just while you were talking there, Charlie, I thought of another one. So it's not how she's playing is not just based on physical condition. Did anybody say mental condition in their list? You know how some games you go into it and you're just psyched out for some reason, or you get in your head and you just feel like, no, you can't do it, or you're gonna lose or whatever. All right, guys, that is enough discussion. I think you're ready to go on to our assignments, which is page 11. Please have your answers and ideas ready for discussion and sharing on Monday. And that will be it for today. So unless you have questions or concerns, you are welcome to leave class. You guys get outside. Oh my gosh, I'm so excited about the forecast this weekend. Like, I'm just giddy about it. Can't wait for the long bike ride. Get out there and enjoy it. I'll see you guys on Monday. Stay strong and be kind. And stay safe. Ethan, if you're still here, I wanted to hear about your swimming superstition that your team does. Are you in here still, Ethan? Maybe not.